So initially the spring is unstretched, and then we lower the thing until it is at the equilibrium position. So going from here to here, we have lost GPE, and going from here to here, we have gained elastic potential energy. So shouldn't the loss in GPE be equal to the gain in EPE? We have done the calculation, turns out it's not. What is happening here? Why is the loss in GPE not equals to the gain in EPE? Let's think about the forces involved here. As the equilibrium position, there's the weight of the ball, and this is balanced by the spring force, right? But initially here, we have the weight of the ball, but the spring is unstretched, so there's no spring force. So how can we hold it here? Obviously there must be an external force. This external force could be provided by like a hand that is supporting it. Alright? So if we keep supporting it here, then no work is done by this force, because work done is F times delta S. If you want to do work, there has got to be a displacement. So if we just hold it there, then there's no work done. But as the question says, we slowly lowered this thing until it reaches its equilibrium position before we remove the external force. So now there's work done, right? There's work done not just by the external force, there's also work done by the spring force and the gravitational force. But the work done by spring force and gravitational force correspond to changes in GPE and EPE. Alright, so what about the work done by the external force? Now, we want to talk about the direction of the external force and the direction of the displacement. We are supporting the ball here. It's an upward normal contact force. But the displacement is downward. So the force is always cushioning it upward, but the displacement is always downward. So we know the work done by the external force is negative. Guess how much work is done by the external force? It should be 0.392 joules minus 0.785 joules. So the difference is due to the negative work done by the external force. Basically, we are trying to apply the conservation of energy concept to this system here. But we can't do that for this system because this is not a closed system. In this system, we actually have an external force doing work on the system. So if you have external force doing work on the system, then the total energy of the system must change. It does not remain constant. That's why we cannot write out this equation here, because this equation assumes the total energy of the system remains constant, which is impossible when you have an external force doing work on you. Okay? Ta-ta!